One more thing yesterday we did was temperature. It can be measured in 3 scales. There are 3 scales. Scales of measuring temperature. This is the thermometer, this is the bulb of the thermometer, and these are the marking or graduations. Here mercury is filled, this is 0 degree and this is 100 degree. And we know that usually the thermometer, it is marked in Celsius, that is centigrade. This is what? Freezing point of water, and this is boiling point of water. Now, one scale is Celsius, that is degree centigrade. We denote it by 0 degree centigrade. And second scale is Fahrenheit, and we denote it by degree F. Here this is equal to 32 degree Fahrenheit and this coincides with 212 degree Fahrenheit. It means that 0 degree Celsius is the freezing point of water, or if you express the freezing point of water in Fahrenheit, it will be 32 degree Fahrenheit. 100 degree Celsius is the boiling point of water. If you express it in Fahrenheit, then it will be 212 degree Fahrenheit. One more scale, that is Kelvin, and this is absolute scale. This is also called as SI system, that is System International Unit, and we denote it by K. Now, if we write here in if we express the freezing point of water in Kelvin, then it will be 273 Kelvin. Means 0 degrees, if we express it in Celsius, then it will be 0 degree Celsius. If we express it in Fahrenheit, then it will be 32 degree Fahrenheit, and if we express in Kelvin unit, then it will be 273 Kelvin, and here it will be 373 Kelvin, and this is called as absolute scale. Now, you can convert Celsius into Fahrenheit and also Celsius into Kelvin. If you want to change Celsius into Kelvin, then directly you will have to add 273, then you will get in Kelvin. But for changing this into Fahrenheit, suppose whatever degree Fahrenheit is given, that will be equal to 9/5 degree Celsius plus 32. Here you see the difference in between these two, that is 212 minus 32. The difference comes equal to 180. And here you see the difference, that is 100 and 0. The difference is equal to 100. That is the reason we are taking here 9 upon 5, 180 divided by 100. So, this is how conversion takes place. Now, one more term which is mentioned in your book, that is evaporation. What is evaporation? If suppose you keep some water in a container and leave it open for a day or two, what will happen? After a day or two, you will see that hardly there is some water left in that container. Sometimes if water which you have kept, the quantity of water which you have kept is less, then you will see that after 1 or 2 days there is no water left in that container. Where that water has gone? That water has evaporated. Evaporated means the liquid water, it has changed into gases or vapors, and where it has gone into the atmosphere. This process of changing of liquid into gas below its boiling point, this is called as evaporation. Change of liquid to gas below its boiling point is called as evaporation. Now try to understand, children, how this evaporation takes place. Suppose this is a container in which I have kept some water. This is water, and this water, it is having particles a little far away. These particles are little far away, and these particles, they are continuously in motion, they are continuously moving. Now inside there will be nothing, but on the surface, suppose these particles, they are also moving. These particles, they are moving in all the direction, and some particles, what happens when they move, then they come out here, they go into the atmosphere, and now this liquid will have less number of particles. In the same way, say this particle also goes. Because of the kinetic energy, it is in motion and it also goes into the atmosphere. So number of particles will be less. In this way, the quantity of water gets less and less, and these particles, as they go into the atmosphere, due to continuous motion, and they possess kinetic energy. So in this way, evaporation takes place. It takes place only from the surface, not throughout. It is not taking here. These particles, though they are moving, but they are not able to come out of that water. Only surface particles, they are coming out and going into the atmosphere. So this is a surface phenomena. It is not a bulk phenomena. Bulk phenomena means it should take inside also, right? And what is boiling? When we boil, if suppose this is a container and we are heating it, then water, this is water, you will see that this water, the whole of the water, it moves. It does not happen that only this surface water moves. The whole of the water which is present here, 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 everywhere it moves. So this is boiling, and this is evaporation. As I told you that evaporation takes place only from the surface, and boiling takes place throughout the you can say throughout the body, means the complete water, it is in complete water you will see that motion is there. So, this is a bulk phenomena and this is a surface phenomena taking place only from the surface. So, this is about the evaporation. Now, factors affecting evaporation. Next topic is factors affecting evaporation. First factor is surface area. Surface area means if you will keep the water open in an open container, say this is a container and I am keeping water in this. So, surface area which will be exposed to water will be this much, and if I keep water in this container, I am keeping water in this container. So, how much surface area will be exposed to water? Only this much. So, in which case evaporation will be faster? In this case evaporation will be faster because here surface area which is exposed to air of water, it will be more. So, if surface area is more, rate of evaporation will be more. Then next is increase in temperature. If you increase the temperature of water, or suppose you start heating this water, then what will happen? Evaporation will be faster. Why evaporation will be faster? Because more of the particles of water, they will get more of this heat energy they are absorbing. So, their kinetic energy will increase, they will move with more speed and they will go into the atmosphere or into the air with more speed, or more number of particles will go in the air, and you can say that more number of the rate of evaporation will be faster. This is our common experience, children, that in hot summer days, when we try to, means when we washed clothes, they are spread for getting dried, then in summer season they get dry faster rather than in winter season. Why? Because air is dry. Air is dry means it does not contain water vapor. It does not, it is hot, its temperature is more, so a rate of evaporation will be more, and that is the reason that the clothes they dry faster in summer season, because evaporation is faster. Then next is decrease in humidity. What is humidity, children? The amount of water vapor which is present in the air, that is called as humid or humidity. If more amount of water vapor is present in the air, we say that it is too much humid. If less amount of water vapor is present, then we say that air is dry. So, if humidity is not there or humidity is less, then what will happen? the air will be dry, and if air is dry, then what will happen? In evaporation what happens? The liquid water, it changes into water vapor. So, if already water vapor is there in the atmosphere and by evaporation some more water vapor is coming out in the air, then what will happen? The rate of evaporation will be less. Now, if this humidity goes away, or if you say that humidity is less or water vapor in air is less and you are evaporating water, then what will happen? By heating or evaporating, this water vapor will go into the air and the process will be faster. So, if less humidity, if there is less humidity, then rate of evaporation is faster. Then increase in the speed of the wind. Increase in the speed of the wind. Usually during summer weather, summer season, you like to sit under the fan. Why you like to sit under the fan? Because due to the hot weather, due to the heat, your body perspires, sweat comes out of the body, and what happens? Fan is moving, and that fan, it is taking away the humidity of the air. So, whatever perspiration or sweat comes on our body, that is fast, that goes faster in the air because of that moving fan or because of that wind which is produced by the fan. So, here if you increase the speed of wind, if it is a windy day, then that wind, it will take away all the humidity or water vapor present in it, and that will increase the rate of evaporation. Then one more thing, that is nature of liquid. Nature of liquid means if we take different liquids and if we see their rate of evaporation, every liquid will have different rate of evaporation. Those liquid which boil, which have low boiling point, they will evaporate faster, and those liquid whose boiling point is higher, they will evaporate with you can say they will take more of, their speed of evaporation will be less. So, you take the example of alcohol and water. Here boiling point of alcohol is low and boiling point of water as compared to alcohol, it is higher. So, this alcohol, it will evaporate faster and water, it will evaporate, you can say if we compare these two, then this will evaporate faster and this will not evaporate so faster as we compare to alcohol. So, it depends upon the nature of the liquid. Then it is our common experience, children, that when we go to doctor for some injection, then what do he do? He first put some with the cotton, he first put that spirit on the body. What happens? That spirit which he puts on our body, its boiling point is low. Boiling point is low means it will evaporate very fast. Then when it is rubbed on our body, it evaporates. It evaporates means it takes the heat of our body to change from liquid to vapor or gaseous state. When it takes the heat, then we feel cool. When we feel cool, then the outer part of the skin, it becomes a little, you can say very little senseless. Sense means it becomes a little numb, and that is the reason when he pricks the this thing injection in our body, then we do not feel so much of pain as we would have felt without the spraying of the spirit. Also, you might have observed that when the players on the ground, they fall down, they get hurt, then the first aid is being first done on the ground only. What do? They spray or they put ethyl alcohol on the wound. Wherever they get wound, that ethyl alcohol is being sprayed. So what happens? The same thing, that ethyl alcohol boiling point is low, so it will evaporate, and that part it will become numb, or the player will not feel so much of pain because of that hurt. And this is how these are all the practical applications of the evaporation. Now there are some differences in between evaporation and boiling, children. As I told you that boiling, it takes place at a particular temperature. Boiling, it will take place at some particular temperature, and evaporation takes place at any temperature. Whatever temperature is there, evaporation continuously takes place. Of course, at higher temperature, rate of evaporation will be higher, but at lower temperature also evaporation will take place. And here boiling will take place only at a particular temperature. Then, as I told you that it is a bulk phenomenon. Bulk phenomena means it is taking place throughout. Throughout means here also, here also, here also, everywhere. But this is a surface phenomena, means evaporation is taking place only on the surface. It is a bulk phenomena and it is a surface phenomena. Here, in case of evaporation, it causes cooling. As I have already told you here that whenever in the summer season, when we sit under the fan, evaporation of our the sweat or the perspiration, it takes place and we feel cool. So in this evaporation, it causes cooling, and here there is no cooling effect. In boiling, so these are the differences, these are the points of differences in between boiling and evaporation. Now, practically, when we try to cool anything, then instead of cold water, or you can say in practical application, when we use cooling effect, then usually ice is being used instead of cold water. Ice gives more cooling effect than water. Come on, let us see. If suppose somebody gets burned, then in that case, instead of applying cool water, if we apply ice on that particular region, that particular place, then it is more effective. Why? We are supplying, we are applying cold water only at 0 degree only, and ice also is at 0 degree. But instead of this water at 0 degree, ice will be more effective. It will give more cooler effect on that burnt skin. Why? Because this ice, it has latent heat of fusion. Latent heat of fusion means we have seen that when we change ice into this solid into liquid, that is ice into water, then there is a kind of heat that is called as latent heat, that is hidden heat, and that is being utilized for changing of the state, but no change in the kinetic energy. So, it is having less heat, and this water, though it is cold, but it is having more heat. Why? Because in water is liquid and ice is solid. So, that heat energy, it is being utilized for changing the state of the matter, that is liquid to solid, and that is the reason that ice gives more cooling effect rather than cold water. So, this chapter is over, children. Almost everything I have given you. Questions will be based on this theoretical part only. Concept must be clear. Go through once, one time, two time, three time, again and again listen this and try to follow whatever written material will be given, study material will be given to you. Go through that also, listen to this CD also and try to understand. And if the concepts are clear, then you can solve any kind of the problem which is based on these that is evaporation, freezing, boiling, all these things. Okay. So, best of luck, children. That's all for this chapter.